Morning. This is a home studio recording of a talk given at the Atlanta Conference on Science and Innovation Policy on May 14th, 2025. The talk is about what a few of us are calling the Bell Labs X project, a vision for reinventing the 21st century equivalents of corporate research labs like the iconic Bell Labs of the 20th century. These corporate research labs dominated the research enterprise of the first half of the 20th century, but became defunct in the second half of the 20th century. The main reason, of course, was the formalization of profits as the prime goal of corporations, a goal that is incompatible with research, particularly the basic research that produces public goods, science, and technology. Instead, academic research is now dominant. The main reason, of course, was the rise of federal agencies like the NSF, whose near total focus was on academia. That near total focus, however, is not fundamental. Federal agencies could easily fund research at corporations, not just in academia. Moreover, there is a compelling reason to do so. Utility and learning are cyclical and build on each other. In one direction, learning serves as starting point for utility. This is translational research, which academia excels at and which is robustly funded. In the other direction, utility serves as starting point for learning. This is reverse translational research, which corporations in principle excel at. Corporations are where utility lives and breathes, and where real-world problem-rich environments and inspiration for learning lives and breathes. But this reverse translational half of the cycle is nearly absent, hence is what the Bell Labs X project aims to reinvent. Here's an outline of the talk. I've just given a simplified history. Apologies if it was too simplified, of our research enterprise. Next, I'll describe in a little more detail reverse translation and how it fits or should fit in the research enterprise. Third, I'll describe a strawman funding and organizational model for harnessing corporations to fill the reverse translational half of the cycle. Fourth, and finally, I'll discuss a few policy challenges associated with the strawman model. Let's start with reverse translation and the utility and learning cycle. Here I've drawn 4 R&D rubrics, each a permutation of whether utility at the bottom or learning at the top are the starting or ending points of the R&D. The first rubric is what we might call corporate development. Here we are inspired by utility. Along the way, we might encounter surprise that takes us away from our original use inspiration, and we might occasionally pivot towards it. That's this dashed arc up here. But mostly we don't pivot towards it. We constrain ourselves by our original use inspiration. If we're after a Moore's Law improvement in chip scaling, that's what we're after. The second rubric is what we might call corporate research. Just like before, we are use-inspired, but unlike before, we seek surprise. And when we find it, pivot to it. It's precisely when we are surprised and then work through the surprise that we learn the most. Claude Shannon's exposure to problems in cryptography during World War II and in communications in the presence of noise post-World War II inspired his surprising idea to treat information as a quantifiable and manipulable entity independent of its physical medium, which in turn revolutionized the entire field of information science. This is not to say that information science didn't also benefit AT&T's telecommunications use. That's this dashed arc pointing downwards. But the major benefit, not monetized by AT&T, was to all information science and technology. And the 20th century Bell Labs 1.0 could afford to do that. It could be altruistic and not monetize the enormous social benefits that its research resulted in because it was a monopoly and had monopoly profits. The third rubric is what we might call academic development. Here, we aren't inspired by known real-world use. We are inspired by learning, including simple curiosity. But because most funding agencies care about real-world use, this R&D has grown to have a strong translational flavor. It hopes for real-world utility for tech transfer from academia to corporations. The fourth rubric is what we might call academic research. Here, we are also inspired by learning, again, including simple curiosity. But when we encounter surprise, we pivot to that surprise. This is the kind of blue sky research epitomized by Einstein. Now that we've depicted the four rubrics in this dynamical way, we can see better how the various rubrics nurture utility in learning. Utility is nurtured, and nurtured pretty well, by corporate and academic development. Learning is in principle nurtured by corporate and academic research, except that corporate research is now largely defunct. Why isn't academic research sufficient to nurture learning? Because academia is too far removed from real-world utility. That's its strength, of course. Not all learning should be in knowledge domains connected to real-world utility. But when you learn in knowledge domains that are connected to real-world utility, that learning has a much better chance of itself ultimately leading to spillover real-world utility. Corporate research nurtures a kind of learning that academic research cannot nurture, hence plays an irreplaceable role in the research enterprise. Okay, suppose we wanted to operationalize the corporate research rubric, reinvent it in a 21st century form. We certainly can't use its early 20th century form because monopolies like AT&T that could afford to produce public goods, science, and technology are illegal. So we need a different form. Here I show one possibility, a strawman funding and organizational model with three overarching features. A first feature of the model is that it is a public-private partnership. Corporations, with their real-world use and problem-rich environments, host and cost share. But a separate research funder, one with broad societal benefit in mind, provides the majority of the funding. For concreteness, we might imagine each Bell Labs X having a $120 million per year operating budget and a 20% cost share. So $20 million per year coming from the corporate host and $100 million per year coming from the research funder. A second feature of the model is that funding and execution is at the institution, not individual researcher level. This is very different from the dominant mode of research funding in the US, matrix funding to PIs in academia. Here, instead, research would be executed by research institutes that employ researchers rather than contract with researchers employed by other institutions. Leadership, as it was at Bell Labs 1.0 of the 20th century, would be empowered to nurture and orchestrate the people, culture, and organizational structure of the institute for the singular purpose of research. A third feature of the model is that there would be many Bell Labs X's, all subject to retrospective competitive reselection. In other words, what we propose are competitive, not captive, research institutes. Let's say there were 10 Bell Labs X's, each one cost shared by a different corporate host. On, say, a 10-year cycle, all 10 Bell Labs X's would be evaluated. Only, say, the 7 or 8 Bell Labs X's that were the most productive would be renewed. 2 or 3 would not be renewed. In this way, the population of Bell Labs X's continually evolves by this reselection pressure towards ever-increasing research productivity. Of course, it's easy enough to imagine operationalizing corporate research with such a strawman model. But there are a number of potential policy challenges associated with such operationalizing, and let me mention two. A first broad policy challenge is associated with a cost-sharing architecture. How should IP be handled, and how might that depend on knowledge domain? Do Bell Labs X's in biotech, computation, energy, or education need different IP rules? Should the Bell Labs X's be subsidiaries of their host corporation or more independent 501c3 organizations? How can we avoid under-incentivizing corporations, as they do need to have some incentive to host these Bell Labs X's? But at the same time, how can we avoid over-incentivizing them, as we want the Bell Labs X's to mainly give public, not private, benefit? A second broad policy challenge is associated with the competitive renewal process. Retrospective evaluation is, of course, much easier than the prospective evaluation that is most common nowadays, where research is evaluated at the proposal stage. But that doesn't mean it will be easy. Could the evaluation criteria echo the Nobel Prize criteria in some way? And how might we evaluate across the potentially vastly different knowledge domains associated with the various Bell Labs X's? With that, thank you for your attention.